Okay, happy day 2 of our new unit. Today we are going to be looking at something called a permutation. Before we look at our new concept though, let's review our concept for yesterday. So yesterday, your two key videos that you learned, we looked at counting, right? We looked at specifically the fundamental principle of counting. Right? And it was basically counting outcomes if you have decision 1 that has 2 options, decision 3 that has 3 options, and decision 3 that has 2, right? You could think of it as a tree that gets you the total number of outcomes, or you could do the 2 times the 3 times the 2. And then 2 times 2 is 4, 4 times 3, that tells you that there are 12 different possibilities of where you might end up at the very end of your journey. So that's called the fundamental principle of counting. The other thing we saw yesterday was a factorial. And a factorial is if you are ordering a bunch of different things like letters or people. If you have 12 people, let's say, and you want them to line up, you can do 12 people for the first, 11 people for the second, and so on, 3, 2, 1. Or you can use something called 12 factorial, which on your calculator, just a quick reminder, your factorial button, let's get out of there. If I want to do 12 factorial, I do 12, go to my math button on the far left, arrow over to probability, and scroll down to the 4th option. That is your factorial. So it turns out there's quite a few different ways to line up 12 people in a line. So that's what we talked about yesterday. So taking those ideas, I want you guys to try out these 2 warm-up problems and then check your answers once you're done. Okay, so here are your answers. Number 1 was really a fundamental principle of counting idea. And number 2 was just a quick check on fundamental counting principle. But this one is a little bit easier to use a factorial to make your work a little bit faster. Okay, so now we're going to get on to our lesson for today. So to start our lesson, this is kind of a similar question to what we just did. I want you guys to pause the video, write out the question, and answer part A, and start thinking about how you might answer part B. Okay, so here's your answer for part A. It's a very large number. If you calculate it, make sure you use your calculator for that one. Now, for part B, you kind of get to the point where you start thinking through what it would look like. I have 50 people who are in the race, and I want to think about the top 15, right? If I take away 15 out of 50, that means there's going to be 35 people who are losing this race. And so that kind of helped me think through the fact that 35 are going to lose. So right at the edge of that, we have 36. And the 36 there is because at this point there are 36 options for whoever is 15th in the race, right? And if you think about it, it kind of makes sense. If 35 people are going to lose, right, there's one more than that who are possibilities for the very last slot. Now, I know what this is in my head. I know that I have to start at 50 and pause at 36, but it kind of seems a little bit silly. Now, here's a trick, and this is going to get us to our big idea for the video. If I take 50 people and do 50 factorial, and I line them up, 50 options for first person, 49 for second, 48 for third, times ... I'm also going to show you getting to like 36 times 35 times 34 times ... times 3 times 2 times 1, just to like see the whole list that we're considering. If I divide that by, remember, I don't care about the 35 losers. I don't care what order the 16th, the 17th, the 18th, all the way through the 50th are. So those 35 people, I really don't care what order the 35 people who are losing. I only care about the 15 people who are winning. And remember, this is kind of that crux point. That's the last person who is let in, and there are 36 options for them. Now, if I divide by 35 factorial, maybe I'll kind of color code this just to make it a little bit easier to see. So if I divide that by 35 factorial, I'm dividing by, remember, 35 times 34 times ... 3 times 2 times 1. And what's really nice about that is, notice you're 35, 34, all these in the middle, the 3, 2, 1s cancel. And what you're left with is really what we wanted. What we wanted from the beginning was to start at that 50 and pause right before the end. And just a quick reminder, the way we got that 35, right, was we did what we had for the total, and we took away the winners, and what we were left with was the 35 who will lose. So that's how we got that 35. Now on your calculator, we can easily do this maneuver, and that will make it a lot faster, because thinking about doing that by hand just sounded terrible, right? So I'm going to do 50, math, arrow over to probability, and choose my fourth option. And I'm going to divide that by 35, math, arrow over to probability, choose my fourth option for my factorial. And it looks like it's also a very large number. So 2.94 times 10 to the 24th power. That's a lot of ways. And so this is representing something that's called a permutation. And it's really just a way to make this a more efficient process. So here's something that you're going to want to put in your notebook. This is your big definition for what a permutation is. So a permutation represents all the different orders if you have a certain amount of objects, which we call R objects, and you're taking them from a total of n. So notice here, this is your total, and this is what you're choosing, okay? And this is the big formula. I'll add the total and what you're choosing. And this is the big formula that we use. And I want to give you guys the runner example. The runner example, we had 50 runners, and P just stands for permutation. And we were choosing, remember, our top 15. That's the winners that we're choosing. Okay. Sorry about that. Choose winners. And we're choosing those winners. So using my formula, think back, we take 50 factorial, that represents the order of all the different runners. So you can picture 50 runners standing in a line. And remember, what we divided by on the bottom, we took the 50 and we subtracted what we wanted. We want to know the order of that 15 people. And remember how that gave us 50 factorial over, and then if we scroll back, remember we had on the bottom a 35 factorial. Okay, so I'll put that in a different color, 35 factorial. And then remember what happened was we canceled out, if we look right back here, this is the big area that we focused on. We canceled out everything that we didn't care about, because we didn't care about the 35 people who lose the race's order. We only cared about the first 15, those orders. So that's where the N takeaway R is coming from. It's matching you taking away what you want. And remember on the bottom, that's representing the order of the losing runners. Okay, because we don't care about the order of them. So the way I think about this is on the bottom, you always put what you don't want, the order of the things that you don't really care about. And the reason why it's because that's going to cancel out with the stuff on the top, and you'll be left with only what you want. Okay, now at the bottom of this page, I've got like 4 examples just practicing the notation. So let's practice some of those notations together, and then you can do a couple on your own. Okay, so let's practice 8P3. This might be I have 8 runners, and I want to know the different ways that I could have my top 3. So you would do 8 factorial over the total minus what we want, 8 minus 3 factorial. That's going to be 8 factorial over 5 factorial. And if you think about what this is going to look like, right, 8, 7, 6, when you get to 5, 5, 4, 3, 2, 1, that's the same thing as 5 factorial. And if you have 5 factorial on the bottom, they're going to cancel out with each other. And so we're left with just 8 times 7 times 6. And that's going to be 336 ways. And you might recognize that from before. That's just kind of thinking of if you have 8 runners and you want first, second, third, 8 people for first place, 7 people for second, 6 people for third. You'll notice it's a little bit less useful with something this small, but if we look back at our other race example, if we had 50 runners, it would be very useful to use this formula. So there are certain circumstances when it's more and less useful. Part B is just a little bit more practice with your algebraic skills. So if I have n factorial on the top, I'm going to do n minus 2 factorial on the bottom. Now, remember how in our last example, we were really trying to get the 5 factorial to match with the 5 factorial. Just like in our previous example, these are both represented by same thing as 35 factorial, right? And they matched up on the top and the bottom. So the idea is we took our top and we stretched out our top in order to get it to match our bottom. So n factorial is the same thing as n times, what's 1 smaller than n? That's like 1 taken away from n minus 1. And then another one smaller than that is n take away 2. And then remember you want to do factorial because you would keep going. An example is if I did 7 factorial, right? That's equal to 7 times 7 minus, times 7 minus 1 times 7 minus 2. So that's representing like 7 times 6 times 5. But remember, you want to put a factorial because you keep going from there. That's the tricky thing, because this is representing that you would keep going and do 5 times 4 times 3 times 2 times 1. So you do have to put a factorial right here on the end. Now notice that matches with what we had on the bottom. So these two cancel out and we're left with just n times n minus 1. Or if we distributed that, it would be n squared minus n. So that one's a little bit more algebraic. I wouldn't worry too much about this one. I would worry about understanding A, C, and D, because those are the key big ideas. So why don't you guys pause the video and try C and D out by hand. And then after, I'm going to show you guys a quick calculator trick. Okay, so here's your answer for the first one. The first one, when you start setting up, you might get to the point where you're like, I don't know what 0 factorial is. I'm assuming that most of you guys probably just said, oh, I'll just try it on the calculator. 0 factorial is actually 1. It's kind of weird. It's like if you are organizing the order of 0 things, I guess you could do that in one way by doing nothing. It's just kind of like a little bit of a weird concept. And that ends up being just the same thing as 9 factorial. If you think about what this is representing in words, this is I have 9 runners. I want to know what the order of all the 9 runners are. So that's the same thing as doing 9 factorial, right? 9 people for first place, 8 people for second place, all the way down to the 3, 2, 1. Part D is a little bit interesting as well. C and D are kind of interesting cases. This one works out that you get 9 factorial over 8 factorial. And then remember, we want to stretch out the top. So 9 factorial is really the same thing as 9 times 8 times 7 times 6 times 5 all the way down to 1. So we could call that 8 factorial, and that's how we get it to cancel on the bottom. Now when they cancel, you're left with just 9. What this is this is saying I have 9 runners. How many ways are there to pick first place? And you're like, oh, that's 9, right? Some of these you don't really need to use this formula for. It's really useful, like I said, for problems like the 50 runners, where you can't picture that in your head. Just another quick thing, a way to double check this, if you do it on your calculator, is my calculator is a little old, so yours you might be able to just type it directly. I generally, if I'm looking at this problem here, 9, pick 1, I would have to type a 9, go to my math menu, go to probability, just like where we get our factorial, and notice there's NPR, and that's representing the first number, and then I put my second number here, I put my 1, enter. I think if you have the new calculator, you might be able to just directly type in, there might be little boxes. I could also do something like my part A, 8, pick 3. So I could do 8, math, arrow over to probability, go down to NPR, and so the first number represents my N, my second number represents my R, and I want to pick 3. So it does match my 336. So one thing I want to point out is that being able to do this with a calculator is a great skill, but you also need to understand it by hand. And that's because there are definitely scenarios where if you're overly reliant on your calculator, you won't understand what it's representing. So quick recap, the reason why we took 50 factorial and divided by 35. 50 factorial is all the different ways I can organize and order 50 things for the 50 runners. I don't care about the 35 people who lose the race. So I put them on the bottom because that's representing all the different ways I can order them. And I put them on the bottom because they cancel out is the big concept. Okay, so on video 2, you guys can work through some quick examples with me just to make sure you feel good on a permutation. I'll see you then.